Welcome to our channel. Listen to short audiobooks every day and improve yourself.
David M. Patel, Artificial Intelligence and Generative AI for Beginners, The Complete Guide. For over a century, humans have imagined a future world where machines could think, create, and learn like humans. Well, that world is no longer theoretical, it's here. From chatbots like ChatGPT to autonomous vehicles, AI has become an integral part of daily life, transforming industries such as healthcare, entertainment, and retail. Whether you're a tech enthusiast or completely new to the topic, understanding AI is no longer optional. It's essential. We'll break down the basics of AI, exploring how it works, the role of machine learning and neural networks, and the revolutionary potential of generative AI to create original content. You'll discover how AI is reshaping industries, from delivering personalized healthcare solutions to redefining creative fields like music and art. At the same time, we'll tackle the ethical challenges it brings, including data privacy, consent, and biases in AI-generated content. Whether you're seeking to enhance your career or simply want to stay informed in this fast-evolving world, now is the time to understand and harness the power of AI. The foundations of artificial intelligence. Artificial intelligence, or AI, might sound intimidating, but at its core, it's about empowering machines to enhance human intelligence. Essentially, AI systems are designed to learn from data, adapt to new inputs, and make decisions, often faster and more accurately than humans can. From virtual assistants like Siri to self-driving cars, AI is becoming a bigger part of everyday life, and it's reshaping industries like healthcare, finance, and education. AI works through intelligent agents, systems that observe their surroundings and make decisions based on the information they process. For example, AI in healthcare helps diagnose diseases and craft personalized treatments. And in transportation, it powers safer, more efficient autonomous vehicles. The journey of AI began in the 1950s with researchers like Alan Turing, who posed the question of whether machines could think. Over the decades, AI evolved from theoretical concepts to real-world applications, with machine learning and deep learning driving incredible advancements. These technologies enable machines to understand speech, recognize faces, and predict trends. However, as AI grows more complex, challenges arise, such as understanding how AI makes decisions, the black box problem, along with concerns about data privacy and bias, which remain critical to address. There are some key components of AI to be aware of. Natural language processing, or NLP, enables machines to understand and generate human language, allowing for smoother interactions with tools like chatbots or voice assistants. Computer vision allows AI to analyze and interpret visual data, such as recognizing objects in photos or videos. Expert systems simulate human decision-making by following a set of rules, helping solve complex problems in fields like healthcare or finance. Finally, robotics extends AI into the physical world, powering self-driving cars, robotic surgery, and more. At the foundation of all of this are data and algorithms. Data provides the experience AI systems need to learn, while algorithms guide how they process that information and make decisions. With this foundation in mind, let's take a closer look at how machine learning specifically enables AI to grow smarter over time. Understanding machine learning and its key types. Machine learning is a key aspect of AI that allows systems to learn and improve based on data. Instead of being explicitly programmed, machine learning models use patterns and experiences to make decisions. It's split into three main types, each suited to different tasks. Supervised learning is the most common type. In this method, systems are trained using labeled data, where input is paired with the correct output. For instance, a model trained to detect spam emails uses examples labeled as spam or non-spam. Once trained, it can make predictions on new, unseen emails. Similarly, supervised learning is used to predict house prices based on features like location, size, and historical sales data. Unsupervised learning works without labeled data. Here, the system finds patterns or relationships in the data on its own. A classic example is customer segmentation, where a model groups users based on their behavior, allowing businesses to tailor their marketing efforts. Another example is recommendation systems, such as Netflix's algorithm, which suggests movies or TV shows based on past viewing habits, without needing predefined categories. Reinforcement learning is distinct because it teaches systems to learn by interacting with their environment. The system receives feedback in the form of rewards or penalties and adjusts its actions to maximize long-term success. This method is widely used in robotics and gaming. For instance, self-driving cars continuously learn from their environment to improve driving strategies. Similarly, AlphaGo, a gaming AI, learned to play the game Go by competing against itself and refining its tactics based on results. Each type of machine learning excels in different scenarios, whether labeled data is abundant, patterns need to be discovered, or interactions with an environment are required. These learning methods have paved the way for more advanced AI models like neural networks and deep learning, which tackle even more complex tasks. Let's take a closer look at those. Mastering neural networks and deep learning. Neural networks and deep learning are foundational technologies in AI, mirroring how the human brain processes information. Artificial neural networks, ANNs for short, consist of layers of interconnected nodes or neurons that process data, making decisions based on learned patterns. These networks are trained using backpropagation, a process that allows them to adjust their internal settings, or weights, to minimize errors and improve accuracy over time. Think of it like the brain learning from mistakes. After each error, the system tweaks itself to get better. Deep learning enhances this concept by adding multiple hidden layers to these neural networks, which allows them to identify more complex features and patterns. For instance, in image recognition tasks, early layers might detect simple shapes, while deeper layers recognize detailed features like faces. This structure enables deep learning models to handle vast amounts of data and tackle complex tasks that simpler models would struggle with. Two specific types of neural networks are particularly useful in specialized tasks. Convolutional neural networks, or CNNs, are highly effective for image-related tasks. CNNs process grid-like data, such as pictures, by scanning for patterns like edges and textures. They excel in facial recognition, medical imaging, and object detection. For example, in healthcare, CNNs are used to identify anomalies in medical scans, such as detecting tumors. On the other hand, recurrent neural networks, shortened to RNNs, are designed for sequential data, making them perfect for tasks like language translation or speech recognition. Unlike traditional models, RNNs retain memory of previous inputs, helping them predict the next step in a sequence. While they're effective for short-term memory tasks, they struggle with long-term dependencies, a limitation addressed by advanced models like long short-term memory networks, which extend their ability to remember information over longer periods. These advancements in neural networks and deep learning have laid the foundation for generative AI, which builds on these principles to create new, original content like images, text, and even music. In the next sections, you'll take a closer look at this evolving technology and the exciting possibilities it offers for the future of AI. The basics of generative AI models and their potential. Generative AI is one of the most exciting areas in artificial intelligence, capable of creating new content such as text, images, and music. Unlike traditional AI models that focus on analyzing or predicting based on data, generative AI models learn patterns from large datasets to generate fresh, unique outputs. These models can generate anything from poems to realistic images and even music, demonstrating a level of creativity that mimics human abilities. Up until now, you've been looking at what are called discriminative AI models, which focus on categorizing data. They are used for tasks like classifying emails as spam or not spam, diagnosing diseases from symptoms, or recognizing objects in images. These models are trained to separate data into specific classes based on patterns. In contrast, generative models go beyond categorization and learn to generate new, creative outputs by understanding the underlying data structure, such as creating text, images, or audio that resemble the training data. Several types of generative models power these advancements. Generative adversarial networks, also known as GANs, work through competition between two networks, one generating new data and the other evaluating it, pushing the system to create highly convincing outputs like realistic images or art. Variational autoencoders, or VAEs, another type, compress input data and recreate it, allowing for the generation of new content with similar characteristics. Transformer-based models, like GPT-4, are highly effective in processing sequential data like text, making them fundamental to the creation of language models. The applications of generative AI are vast, with tools enhancing industries like art, design, healthcare, and marketing. AI models can now write news articles, create visual content, assist in drug discovery, and even generate complex video sequences. As generative AI continues to evolve, learning how to communicate effectively with these models through prompt engineering will be the key to unlocking their full potential. In the next section, you'll learn some basics of prompt engineering. Prompt engineering for effective AI interaction. To get the most out of generative AI, you need to know how to communicate with it effectively. This is where prompt engineering comes in. Crafting clear and precise prompts is essential to guiding AI, such as ChatGPT or DALL-E, to create the output you want. The better your prompt, the more likely it is that the AI will deliver accurate and relevant responses. Prompt engineering is about more than just the content of your request. It's also about how you structure it. For example, short and clear prompts allow AI to process more efficiently, leading to better results. If you give a concise instruction like, write a 100-word summary on climate change, you'll get a targeted, concise output. On the other hand, a more creative task, like generating an image, might require specific details, such as, create an image of a sunset over a city skyline with futuristic buildings. Understanding key concepts like tokens and context windows will improve how you interact with AI as well. Tokens are the building blocks of text models, and every prompt uses them. A context window refers to the total number of tokens the model can consider at once, defining how much information the AI can process in a single response. If you give a lengthy input, the model may leave out details due to this limit. To avoid this, aim for brevity and relevance to ensure more accurate and detailed responses. Different types of prompts yield different outputs. Instructional prompts, like explain how to change a flat tire, will generate step-by-step guidance, while creative prompts lead to more imaginative responses. You can also tailor prompts for specific needs by controlling the tone, length, or format, like requesting a formal tone for professional emails. Finally, don't forget to experiment with your prompts. Iteration helps refine your requests and optimize results. Mastering these techniques will ensure you can fully leverage AI's capabilities, helping you craft exactly what you need. In the final section, we'll explore how AI is transforming entire industries and the ethical considerations this revolution brings. The future impact of generative AI and ethical considerations. Generative AI is poised to revolutionize industries, already transforming fields like healthcare, entertainment, retail, and beyond. By harnessing AI's ability to generate creative content and streamline complex processes, industries can look forward to enhanced efficiency, deeper personalization, and groundbreaking innovation. In healthcare, for example, AI will accelerate drug discovery by designing new compounds and creating personalized treatment plans based on individual genetics and lifestyle. Medical imaging will also benefit from AI's ability to generate synthetic images and detect anomalies, making diagnosis more accurate and efficient. In the entertainment sector, AI will play a key role in content creation. From composing music to generating film dialogues and designing immersive video game environments, AI will transform the creative process, making it faster and more personalized for audiences. Retail and fashion industries will also benefit as AI can enhance customer experiences through personalized product recommendations, custom clothing designs, and efficient inventory management. Generative AI's potential doesn't stop at consumer-facing industries. In architecture, it will optimize design processes by generating innovative structures that reduce material use and cost. The automotive industry will see advances in both vehicle design and autonomous driving technology, where AI will interpret sensor data to make driving decisions, propelling advancements in safety and performance. However, alongside these transformative possibilities come pressing ethical concerns. Issues such as data privacy, consent, and bias in AI-generated outputs must be addressed to ensure responsible usage. The creation of deepfakes and misuse of AI-generated content highlights the need for transparent and accountable systems. Additionally, copyright infringement, particularly when AI models use existing creative works without proper attribution, presents legal challenges that must be addressed. Despite these ethical complexities, the future of generative AI holds immense promise. As AI becomes more integrated into daily life, offering more accessible tools and enhanced personalization, it will push industries toward unprecedented levels of innovation. By adopting responsible development practices, we can ensure that this transformative technology reshapes industries ethically and effectively. This is just the beginning of an exciting era of progress and possibility. To Artificial Intelligence and Generative AI for Beginners by David M. Patel is that AI is revolutionizing how we work, interact, and create. Through advancements in machine learning, neural networks, and generative AI, industries are seeing unprecedented innovation, from personalized healthcare to creative fields like music and design. While these developments are exciting, they also raise ethical concerns regarding data privacy, bias, and responsible use. Ultimately, AI offers enormous potential for positive change, and learning how to harness it will prepare you for the future ahead.